start with basically the overview, right? So does anyone know another word that we can consider the heart as? Well, can anyone tell me what the heart does? What's one of its functions? You can either type it in the chat or unmute yourselves. So people are saying pumps blood, lets you breathe. So the heart doesn't necessarily let you breathe. That's more with like the lungs itself and the respiratory system. But we can find out the connection between the heart and the lungs. So yeah, so as you guys said, yeah. So considering what the heart does, right, it helps pump blood to the rest of the body. So I'm sorry if I say your name wrong, Camilla? Camilla? Camilla's right. The heart's a muscle. So the heart is able to pump blood because, muscles contract. They restrict and they contract. Yep. So thank you. So yep, the heart is a muscular organ that acts as a pump. So it can help send blood. So it can help send blood to the rest of the body. So 1 second. So I'm going to quickly just press the record button, I believe, if that's an option for me. Oh, okay. Someone's already recording. Okay. So the heart is located under the sternum, so kind of this this large bone. And some of you may have kind of maybe heard that like on Grey's Anatomy or some medical TV show, how they have to like crack it. Yeah, and it's in the thoracic compartment called the mediastinum. So an average size heart is about the size of a man's fist, and it weighs around 250 to 350 grams, which is kind of less than a pound. But does anyone know like the go-to measurement for the size of our own heart? So someone said not really. Okay. Well, the heart is actually, we can use our fist as like a judgment of the size of our heart. So for like children, it's the size of like one fist. And depending as you grow as an adult, depending how kind of tall you are or like your body size, that also depends on how big your heart is. But for adults, the kind of go-to is 2 fists. But the reason why an average size heart is the size of a man's fist is because typically men are bigger and they have larger hands than we do. Or well, than I do, and some of us here as women. So the pericardium surrounds the heart, where the fluid inside can lubricate the outer wall of the heart. So why should there be lubrication for the heart when it's pumping? Easier to move? Yeah, so it would be easier to move, Anyone else have any guesses? But yeah, as Carissa said, it does make it easier to move in the sense that with the lubrication, right, there's not as much friction, right? So it's smoother and it doesn't cause any damage because like, like when your own skin like kind of goes against the floor or like a rug really fast, you kind of get like that rug burn. Well, that can similarly happen to the heart. But with the lubrication, it allows the heart to move smoother and without any complications of like burning. And it also helps form a barrier against infections and the prevention of overexpansion. So sometimes, I don't know if you guys have heard, but the heart the heart can move, kind of like grow smaller than its size, but also get bigger than its own size. So we don't want the heart to get bigger than it is because there's no room, right? Everything in our body fits kind of like a puzzle. So we have the colon, the liver, the stomach, the heart, and the lungs. And then over we have the ribs so we can protect all these organs. But if the heart grows bigger, there's not really that space for that because everything fits in kind of perfect. So the heart chambers. So the heart consists of four chambers, the two atria, and the two ventricles, right? So the superior chamber consists of the right atrium and the left atrium, okay? And then the lower chamber consists of the ventricles, right? So the right and the left. And so the right atrium, this right here, receives oxygen poor blood and pumps it into the right ventricle. So this thing right here. And then the left atrium receives oxygen-rich blood from the lungs, right? And pumps into the left ventricle. So with this little blurb we find here, right? So the left atrium gets the blood that has the oxygen from the lungs and pumps it from the left ventricle. So can anyone kind of tell me the relationship between the lungs and the heart? Does anyone want to take a shot? Someone said the lungs get air and the blood gets it all over the body. Yeah, right. So when we're breathing, right, we have breathing in the air, and then the oxygen from the air is actually what we want, right? So that goes into the lungs. And then we have these pathways that we're going to learn about later that leads into the lungs, but also from the heart into the lungs. So the blood can get the oxygen, right? So the blood can go, so we have oxygen to the rest of our body to reach our muscles. So we can do like a bunch of activities because our entire body just needs oxygen. Okay. So then the left atrium receives oxygen-rich blood. I already said that. Sorry. The auricle, a small appendage, expands the volume of the chamber. So as sometimes when our heart, right? Our heart is just pumping without us really needing to. So there's not something we can do as people to really kind of change that. So this part of our heart kind of helps regulate the amount of blood that's being pumped, and because sometimes there could be too much blood and it just keeps going. But we're also going to learn further on another way of regulating like how much blood flow occurs. And then the two ventricles are separated by the interventricular septum, which is a myocardial wall. So this part right here, it separates the two sides of the heart. Okay, so let's kind of see what we know of the heart and what we can point out. So if anyone wants to unmute themselves, because it's kind of hard to do it over chat, tell me what they believe is parts of like what they think is a certain part of the heart. And you don't have to be shy if you don't know or maybe get it wrong. Just any familiar words you may have heard about the heart and about the different chambers or valves. You said the last slide with all the explanations? Okay, well, I only have around 20 minutes left, so I'm gonna post this on Google Classroom. So it won't be a problem. You can just go back to the slides. So just for purposes, right? So we have the aorta here. We have the right atrium, the right ventricle, the left ventricle, and the left atrium, right? So in our body, right, our heart is the opposite of how others see it, right? So if I'm facing one of you guys, my left and my right, my left atrium and ventricle are being opposed to yours. Okay. So next, we're going to talk about the circulation system. Okay. So we kind of went over a general idea, but so first the aorta pumps oxygenated blood out of the heart into the rest of the body. So basically, so going to our brain, to our arms, our legs, every part of our body that would essentially need oxygen. And then the deoxygenated blood, so the blood without oxygen, returns to the heart through the superior vena cava and inferior vena cava into the right atrium. So does anyone know what we consider the vena cava, these two, as? Okay, well, no one said anything, but these are veins. So they help return the blood back to the body. So based on the signals of the SA and AV node, so in case anyone does not know what that is, basically the SA node is it generates electrical signals for the atriums or the atria to contract. And then the AV node is what kind of is in function after the SA node, and that's what causes the ventricles to contract. So then the right ventricle pumps the blood without oxygen, so the deoxygenated blood, up to the pulmonary artery. And then the oxygenated blood leaves the lungs and returns to the heart through the pulmonary veins and then enters the left atrium. I can just go back. Yeah, so the aorta, yeah, has the blood with the oxygen because it just came from the lungs. So the aorta has a pathway to the lungs. So that's how it has the blood with oxygen, yeah. Yep, so then the oxygenated blood leaves the lungs and goes to the heart through the pulmonary veins and then goes into the left atrium. And then in the left atrium, it pumps blood to the left ventricle to then go to the aorta and then start over the process again. So the whole pathway is kind of like a figure 8, you know, and I think there's a picture on the next slide that shows that. So yeah, we have a circulation diagram. So if we see, right, so, oh, it doesn't let me go back. I'm not sure why it doesn't let me go back. I don't know if anyone from the Myri-Ed team can help me how to go backwards. Oh, here it is, sorry. Okay, right, so we see that here's our lungs, and so on this side, it's kind of like, so I'm sure you guys know the difference between the red and then the blue. So this has oxygen and this doesn't have oxygen. And they have it blue just for simplification purposes. But in reality, the blood with oxygen is like a brighter red, and then the one without is the like a darker red. So you can see like the pathways leads into the heart. All places are stomach, so like all the intestines, kidneys, our legs, and then it goes back up. So all the blood without oxygen goes back up into here. So this looks a little bit more confusing because there's a lot of like different routes. But essentially it is like a figure 8 because it's like in the heart itself. It goes, I think someone wrote in the chat. Why is the heart under the lungs? Oh, the heart's under the lungs just to show the picture clearly. Yeah, but in reality, the heart is resting on the left side. So even though it appears right to us, remember, for our body, it's on the left side. Okay, so now we're going to talk about some of the heart valves. So the valves are located between each atrium and ventricle and in the 2 arteries that empty blood from the ventricle. So we have the pulmonary valve, the tricuspid valve, the aortic valve, and the mitral valve. And they're made of connective tissue that originate and extend from the heart walls. So the valves open and close in response to the different pressure changes in the ventricles. And this change in pressure allows the blood flow into the ventricles and from the atria without restriction. So some of you guys may have seen, if you ever like looked up like a heart or seen a heart in real life, like heartstrings. So the heartstrings, you can kind of see them here. They're like this thin little, I don't know how to say them, lines or like, actually, like, I guess you could say they're like strings. But yeah, so we have like those little heartstrings that connect to the valves to help them move. Okay, yeah. So with the pulmonary valve, it's located in the right ventricle and is a way for blood to leave the heart through an artery. And then the aortic valve is between the left ventricle and the aorta, which hence its name, and allows the blood to go to the aorta. Then we have the tricuspid valve, which is made of like 3 flaps that controls blood flow from the right atrium to the right ventricle. And then the mitral valve, which is only of 2 cusps or like flaps that regulate the blood flow from the lungs into the ventricle, the left one. So then we have some coronary arteries and veins, so the most important ones. So here's an anterior view of the heart. So we have a lot of veins and arteries connecting from the heart and into the rest of our body. So the 2 most important are the left main coronary artery and then the right coronary artery. So this supplies blood to the left side of the heart, but it also divides into 2 subsections, which is the left anterior descending artery and then the circumflex artery. And then with the right coronary artery, it supplies blood to the right side of the heart and the SA and AV nodes, and then the 2 like subsections, which are the right posterior descending artery and the acute marginal artery. So can anyone tell me what an artery does? Like, where does it bring, what's its pathway of blood? Yeah, so sorry, I don't know how to say your name. Camilla, as Camilla said, right, arteries bring blood away from the heart and to the body. So then coronary vein, so here's the other side of the heart. So these are the most important veins. I mean, we have tons, but these are the ones that have that do like a lot of the work. So I'm not gonna say the names just for time purposes. But we can see some of them. So the great cardiac vein is right here. So around 80% of the deoxygenated blood returns to the right atrium from the myocardium. But the cardiac veins help prevent backflow or the leakage of blood back into a chamber. So why might it be good that we don't have blood going back into the chamber? So kind of going the opposite way. So Andrea said to prevent having too much blood flowing. So that is on the right path, right? So we don't want to have too much blood going the wrong way, you know? Because if blood were to leak back into a chamber, um, that's kind of disrupting the cycle of the way the blood's supposed to flow. So our last kind of main idea would be the conduction system. So conduction pathways, right? If we look in the picture, so it's like these electrical impulses that go throughout the heart, which actually cause the heart to contract and be able to make the blood go in the direction they want to. So it consists of cardiac muscle cells and conducting fibers to initiate impulses. And it provides the heart with its automatic rhythm. So if you guys have seen on any medical TV show how they can use like those, they can like use this electrical thing to make someone's heart work again, it's because we actually have this like electrical impulse system in our own heart. So by manually kind of electrifying our heart, that's what allows it to start pumping blood again. So then for efficient circulation, the events in the cardiac cycle must be coordinated. And in case you don't know, the cardiac cycle is a sequence of events that occurs when the heart beats. So diastole and systole. So if you guys haven't heard those terms before, systole is when the heart actually contracts to pump blood. So if you see like the ECG or like the TV where it shows like the heart rate, the part where it goes up, like the spike, that's systole. But diastole is when the heart relaxes after contraction. So that's the like kind of straight line before it goes back into systole. Okay, so I have this video that can kind of put everything we learned into more of a visual aspect. Oh, sorry. I didn't realize I forgot before Zoom you have to click enable computer sound. But I'm just gonna go with the rest of the video, and you guys can watch it with sound after class if you'd like, because we only have maybe around 5 minutes left. So as you see, like the kind of electrical impulses, so they're kind of, um, it doesn't actually look like this if we were to see a real heart being kind of shot with these impulses, but I guess for visual purposes, it looks nice to see how, like, when it shocks, the valves open and close. Okay, so now let's try to be the doctors, right? So say this adult is having like really bad chest pain and they're feeling lightheaded all the time and they have shortness of breath and it really affects their daily life because they can't really do as many of the activities as they wanted to. And so they went to the doctor and the doctor said that one of their heart valves are damaged. So what should we do? How can we fix this problem? So Nathaniel said replace it. Carissa said, does he need surgery? So does anyone else second what they say? So Camilla said artificial valves. So you guys are all on the right track. Yeah. Does anyone else agree with them? Okay. Well, I would hope you guys would agree because oh, Nathaniel said robotic valves. So robotic, sort of, but not exactly in the robotic sense. So yeah, someone said, whoever said replacement and like artificial is right, along with having surgery because that's the only way we can actually replace it. So with heart valve disease, they need surgery. And this happens with like rheumatic fever, endocarditis, cardiomyopathy, and all of these things can result in the stiffness of the valve or valve regurgitation, which is when the blood goes back up the chamber, which means that the valve isn't doing necessarily its actual job. So yep, we're gonna have to do a surgery for this. And around 94% of these surgeries are successful, but depending on your age and how good your health is, obviously affects this. And some of you already answered kind of like the how question. So you can either use a mechanical valve or a valve made from a cow, pig, or human heart tissue. So I believe artificial valves are still kind of like in the works because with like biomedical engineering, having artificial organs and making things as real as they could be, but still kind of making it sustainable. So without like taking it from other beings is kind of like the new age. Human heart tissue. So human heart tissue, this basically just means they're gonna make a valve out of like the tissue of a heart. So like they would take like an actual valve from a heart and construct it into another person's heart. But I don't believe this is very popular because So do you have to constantly replace the valve? Yep, so the valve does wear out and they do have to replace it, I believe I'm not sure, but my guess would be maybe every 5 to 6 years, or maybe longer. So here's some pictures. So here we have the mechanical valve, right? Doesn't look really realistic compared to like an actual valve, as we see here. So we have one of a pig, and Camilla, who said artificial valve. So yep, this is like a 3D printed one, and it looks more realistic than the mechanical one does. And down here, it shows like the different parts, I guess, labeled. So this would be like the kind of closing part, except it's just as a rectangle. It's supposed to be that small. So it is supposed to be that small. Yep. So valves are not really as big as we may think it is. And the reason why we use valves from a pig or a cow is because their hearts are about our size. Yeah, so valves are tiny. Yep, valves are tiny. Because I mean, like, if we take the idea that the heart is the size of like your fist around, our heart really isn't that big. And the valve obviously can't be that big if our heart's not that big to begin with. But yeah, depending on your body size, valves would be bigger for you. So like I know me compared to like a 6-foot adult male, their valves would be bigger than mine would ever be. Okay, so thank you guys for coming. If you have any other questions of anything you learned or are confused about or just want to talk more about, you can email me. Um, and I'll also be sending a Google Forms out within the next week or so because I only planned 6 lessons because I wanted this class to be more like based on what you guys want to learn rather than because if it's something you guys don't want to learn, then I don't want to be teaching it and you don't feel like it's exactly enjoyable to listen about. So yeah, thank you all for coming. If you have any questions, you could just tell me now. No problem.